Hi everyone, in this video we are going to solve a problem. The problem name is jump game 4 and the problem number is 1345. Alright, so first of all we are going to clearly understand what this problem says. After that we are going to move to the logic part and after that we are going to implement our logic in C++, Java and Python programming language. Fine, now let's see what this problem says. Given an array of integers ARR, so we are given with an array of integer data type. You can see in example 1. You are initially positioned at the first index of array. So guys, initially we are at the 0 index of our array. Fine. Now in second line it says that in one step you can jump from index I to index. So guys, there is a condition. We can jump from index I to the first condition is I plus 1. We can move to I to I plus 1. But the condition is I plus 1 should be the less than array dot length, right? Okay. The second we can move I to I minus 1. But I minus 1 should be greater than or equal to 0. Fine. And we can move I to j. Now what is this j? So the j index is nothing but guys the index of that particular value which has the same data as the array of I. So in example 1, if you notice that we have 100, right? So my ith data is nothing but 100. So can we have a same data, 100 data anywhere in our array? Yes, we have here. What is the index of that particular? That particular index is, let's say, is 4. So this is nothing but j. So we can move I to j. We can move 0 index to 4 index because they have same data. I hope this makes sense. Fine. So these were the three conditions to jump from index I to any other index. Okay. Return the minimum number of steps to reach the last index of array. Now guys, the simple question they are saying that we have to find the minimum number of steps we need to reach at the last index of an array, like the last index of your array, we can say, right? So we are at 0, we want to reach the last index, that is nothing but 9 here. So what is the minimum number of steps we need to take, right? Because there are a simple possible answer can be like just increment it, move ahead, move ahead, move ahead, and you can reach to the last index, but it will not be the minimum one, right? So we have to find the minimum number of steps to reach the last index of an array, right? And one more condition, notice that you cannot jump outside of the array at any time. So it says that we can't move outside of that, right? So we can't go 10 or we can't go minus 1, right? So we should be in between of this, right? All right, so that makes sense. So we have understood the questions. If you still have any kind of doubt, don't worry. Let's understand this with example 1 now. So we have this particular example. So guys, what step I'm going to take, which should give me the minimum number. So the first thing which I'm going to do, I'm going to move from 0 index to index 4 because they have same value, right? So 0 index to index 4. Fine. Then second step, I'm going to take 4 index to index 3. You can see here also they have given the solution. So 4 index to index 3 means I come here. I hope this makes sense. Sorry. So 4 index to 3 index. Now guys, the third value, which third step which I'm going to take on is 3 index to the last particular ninth index because they have a same value. So I can say 3 to 9. So it's gonna give me gonna reach me at 9 index with just three we can say the step, right? So I took 3 steps to reach at the ninth index, or we can say last index of an array. So I'm gonna return 3. So this is the possible minimum possible answer we can say, right? So if you take any other step, then it will not gonna take a 3 step, right? It will gonna take more than 3 steps. If you move 4 to 5, then you can see that 23 can move to 23. So you can come here at the fourth step, then you have to come here, then you have to come here. So it's going to take a 7 step, right? So none any other possibilities can give you the minimum number of possible we can say the steps to reach at the last index, right? So this is the only possibilities which are giving you that you can reach at the last index with just 3 steps. So we have to find these particular things, right? So now guys, I believe by this particular example you have understood their problem, what we have to do. We don't care about right now the logic part, we just want to understand this particular problem clearly so that we won't have any kind of doubt later on, right? So I hope now you understood this. Now let's see how we can solve this particular problem. What should be the logic, right? So let me write here the logic part. So guys, the logic is going to be very simple. If you will listen carefully, definitely it's going to be very simple, right? So the first thing, I don't want you to think about this particular problem as an array. Forget about array. This is not an array problem. Does that make sense? We don't care about this particular values. We don't care about any index, right? Forget about array right now. Now, one thing which you need to be focused here is nothing but graph. I hope this makes sense. Why graph? See guys, we are at I index, assuming we are starting from 0, right? They have already given that you are starting from 0. So we are at 0, right? Now guys, we are given the 0, we can move 0 to 0 minus 1, minus 1. We can move to 0 plus 1, 1. We can move to all those values which have same values. So it is kind of like we can say, what we can say, it is kind of like a list, right? We can say adjacent list. We have a 0, we can 0 to move minus 1, we can move to 1. Or we can move to all the possible, we can say the index where the value are same. So this is nothing but we can say adjacent list we are given with. Now minus 1 we can't move because it is out of bound. 1 we can move. So from 1 also we can move what? We can move to 1 minus 1, that is 0. But 1 to 0 we are not going to move because it is already has been explored. Then we can move to 1 plus 1, that is 2. So we can say 2. And all those values which has all same value with this particular one, right? And has not been explored earlier. I hope this makes sense, right? Fine. So this is nothing but it is going to look like a graph, right? And it is nothing but adjacent list. So I will say that just let's try to explore it here. So we have 100, right, at 0. So we can move to minus 1, but it is going to be out of 1. So we can move to 1, right? So 1 is nothing but has a 23 value. I hope this makes sense. So let me write here it with this color minus 1, and this is nothing but it is going to be also can move to 4 index, right? And on the 1 index we have nothing but minus 23, and here we have nothing but 100. I hope this makes sense. Now guys, you can see that minus let me write here 1, not minus 1. So here now guys, from 1 we can move to 0, but this has already been explored. So it's going to move to 1 plus 1, that is nothing but 2, right? And all those values which are same with minus 23, right? So that also be nothing but 2, right? Second index only, and nothing else, right? Fine. And from 4 we can see that we can move to 3, third index. We can move to 5 index, right? Okay, and not other have a same value. So we can give it a value as well. So 2 is nothing but we can say minus 23. This is also minus 23, and here also we can say 3 is nothing but 404, and here we can say nothing but 23, right? Fine. So this makes sense. So 404, let me write here. Fine. Now guys, from 2 we can move to 3. I hope this makes sense, but 3 has been already explored. This will not be explored if we have done this particular part, but this has been already explored, so we are not going to move to 3 particular part. I hope this makes sense. So we are not going to move 3. We are going to not move to we can say minus 1 also, because 1 has already explored. So 2 is not going to move anywhere. This is also not going to move anywhere. But 3 we can move to 4. But 4 has already been explored. We can move to 2. 2 has already been explored. So 3 also not going to move anywhere. But 3 can move to that particular index where we have a same value, right? So we can say that the 404 having a same value at the last index 9. So it can move to 9. I hope this makes sense. So at 9 we have nothing but 404. Now 5 can move to 6. So 6, let me write here. Now guys, 9 we have reached to the end of the array. So we are going to return nothing but 1, 2 and 3. We took 3 steps to reach the 9 index. I hope this makes sense. So this is the basic part which I have told you about BFS. How does BFS gonna work? And if you still have any kind of doubt, you can write in the comment section. I'm always there to help you, right? So basically this was the problem, and this was the logic. We are going to use a BFS, but for that we need to maintain one particular array, or we can say hash map, where I'm storing the data, we can say 100, and on how many particular indexes does contain the data 100, right? So we will see everything in the implementation part, but by now I want to make you sure that you have an idea how this problem is going to solve, and how you can solve by using a BFS. If you still have any kind of doubt, you can write in the comment section. Now let's move to the implementation part, and let's see how we can implement this particular problem. So first of all, I'm going to do with the Python. So first thing which I'm going to make take care about, that is my queue. BFS take a queue. So we are going to say queue, and queue is nothing but it's going to be DQ. So collections dot DQ. Fine. And initially we are at 0, so it's going to insert 0, right? And one thing also we are going to take care about, that is nothing but dictionary, right? So which is going to be stored the data. So I'm going to say collections dot default date, and this is going to be by default list, right? Fine. So I'm going to say nothing but for value I in range of let's keep it array as well. So n is equal to length of array. I found the length of an array. Now I'm going to say range of n, and I can say here dictionary of arr of I should be equal to ai. I hope this makes sense. I am storing the address of every particular data, but here I can append it, right? So value can be same, so append I. All right. So now this is done. Once this is done, I can say that I'm going to start my BFS, right? But before that, I have to maintain is visited set. So is visited. I can say this is going to be nothing but index. So is visited index, and this is going to be set, and is visited. We can say a value which is going to be nothing but also set. Why I maintain two is visited? Let me tell you. The first one is going to check whether this index has been explored. The second thing is going to check whether this value has been explored, because we can move to same particular value, right? Fine. Now I'm going to use the BFS, so I can say while true. I'm going to say tell me the size of your queue. So tell me the size of queue, and let me explore for I in range of size. Fine. And I'm going to say data is going to be q dot pop left. I'm going to take the left data, and I'm going to say if data is equal to n minus 1, that means we are at the end of index, so we can return that particular steps. So we haven't defined a steps variable, so let me define a steps which initially 0, right? So we haven't taken initially any steps, we are going to return steps. But if data is not equal to n minus 1, we are not at the end of the index. So we are going to say that we can move either minus 1. So I can say if data minus 1 is greater than or equal to 0 and data minus 1 in is not in. So we can say not in is visited idx. So we can say is visited idx dot add. First of all, add this data minus 1. I hope this makes sense. Once it added, let's add in q as well. So q append, let me add append data minus 1. Fine. So once this is done, we have solved this for data minus 1. Same we are going to do with data plus 1. If data plus 1 is less than n and data plus 1 is not in our, we can say is visited, right? Not in, let me add not in is visited idx. So we can say is visited idx dot add data plus 1. Okay, and we can say q dot append data plus 1. I hope this makes sense. And here also we are going to say is visited idx, right? So I have just written is visited dot add. Once this is done, we are going to also take care of that particular value, which is nothing but we can see the same value, right? So we can say if ARR of data, right, ARR of data not in is visited value, not in is visited value, then we can say this value has not been explored. So we can say for all the values, or we can say for j in range of, or we can say j in dictionary of ARR of data. Now you can say we are going to explore all these things. So we can say if j not in is visited idx. So we can say first of all add this particular index as well, is visited idx to add this particular j, and q dot append this particular j. I hope this makes sense, right? So once this is done, we are going to say nothing but let me write here. We have done this particular things, and we are going to add this value as well. So is visited val dot add this particular array of data. Once these all are done, so we know that we have done these particular things. We are going to increment the steps, right? So once we have completed this loops, we can say steps we have taken 1, right? Step plus equal to 1. So now we can say just we have done our solution. So let's try to run this code and see whether we are getting a right output or not. So it will say none type has no return data. Okay, so if j not in, let me write in. Now let's run this code. Let's see that whether we are getting a right output. You can see that all the test cases are passed. So let's try to submit this code and see whether we are getting a successful submission or not. And you can see that guys, we successfully got our submission, right? So we have solved this particular problem using a Python programming language. Now let's move to the another programming language that is nothing but we can say Java, right? So okay, so we are going to use a Java programming language now. So first thing which we are going to maintain is q. So I can say that q. So it is going to be integer data type. So I'm going to say q is going to be new linked list. Have this make sense? Now we are going to take care of hash map. As I have already told you, hash map of integer and list of integer. Let me write integer. And the name I'm going to give is dictionary is going to be new hash map. Okay, and here is going to be nothing but this one. I hope this makes sense, right? Now guys, once we are done this particular things, what we are going to do next, we're going to maintain a set, right? We're going to say is visited, or we can say the hash set, right? Hash set going to be integer, and after that we can say it is going to be nothing but is visited idx is going to be new hash set, right? Once we are done this hash set, we are going to maintain two hash sets. So we let me copy this, and here we are going to say is visited where. I hope this makes sense. Once we are done all these things, now we can use our BFS, right? So while true, we are going to say find out the size, right? So int size is going to be nothing but have, we can say q dot size. I hope this makes sense, right? Fine. Once we are done these things, we are going to say for int I is equal to 0, I less than q dot let me write here size only I plus plus, right? Once we are done this thing, now what we can do, we can say we are going to take the left data. So we are going to say int data is going to be nothing but q, which thing is going to do all, right? So it's going to give the left data. Once we have taken the left data as well, so now we are going to check if data is equal to our n minus 1, and we haven't calculated the n. So let me calculate the n as well. Int n is going to be nothing but arr dot length. So if it is n minus 1, that means we have successfully reached at the last index, right? So we can say return steps, and steps also we haven't defined, right? So we haven't defined a lot of things. So we can say int steps is also going to be nothing but 0. Now once we define these things as well, so we can use it, and we can say now if it is at the last index, so we can return our steps. But if it is not the case, then what we are going to say, we are going to say if data plus 1, if this thing data plus 1 is less than n, and we can say and our data we can say is visited idx dot contains our data plus 1, then what we can say, if it is contain, if it is not contain, right? So if it is not contain, and we can say, let me remove these things and let me write here this particular bracket, right? Fine. So this is done. If it is data plus 1 less than n and is visited index does not contain that particular data, so we can insert that particular data into our queue as well as in index is visited idx to add this particular data plus 1, and also you can add in your queue dot add data plus 1. I hope this makes sense. So same thing we are going to copy. So I'm going to copy this thing and I'm going to say, let me copy this thing, and I'm going to do nothing but paste it over here, right? I'm going to say if data minus 1 is greater than or equal to 0, and it is not in our, we can say, is visited idx, then you can add that particular thing as well, right? So we're gonna add it. I hope this makes sense, right? And one more thing which we can do is value, right? So we can say arr of data. If arr of data is visited and not contain this particular thing, if is visited value dot contains is this particular thing, if it is not contained, right? So we can say that we can explore these things. So we can say visitor val dot contain, first of all add this particular thing array of data, and we can explore all the values, right? So we haven't, now we have to create that particular dictionary, right? So I can say for int I is equal to 0, I less than n and I plus 1, right? And I'm going to say if this particular, we can say, dictionary dot contains key of that particular I, it is does not contain that particular key, then what we have to do, we have to create a particular key, right? So we can say dictionary of, okay, so dictionary dot put that particular key I, and what we have to put, we have to put new array list of integer. I hope this makes sense, right? So we are going to put the new array list. So once we are done these things, we are going to say dictionary dot put, or we can say dictionary dot get. You have to append one thing into your particular dictionary, right? So you are going to now add this particular things, right? So you can say dictionary dot get, you're going to get that particular index and you are going to add that particular, you can say the I, right? So here we are not going to use I, so we are going to use arr of I, right? So if it does not contain arr of I, so you are going to append that particular index on that particular arr of I. I hope this makes sense. We are just maintaining the index of every particular value, right? So now we are going to traverse over that particular index. So we can say for in data of dictionary dot get, and what we are going to pass arr of data. I hope this makes sense. And data is already been defined, so let me keep it a value. So we are going to traverse over this particular thing and we are going to check it if that value, or we can say is visited dot idx, or we can say is visited idx dot contains this particular value, then you don't need to move it, right? So we don't need to do anything if it is contained. If it is not contained, then only we need to move it. So we can say node, and we can say is visited, first of all just you have to add this particular things, add, and then you can say q dot also add this value. I hope this makes sense, right? So once we have done this thing, that means we have explored the particular step, we can say, and after that we're going to increment our steps, and after that we're going to return our steps. And let's see, run this code and see whether we are getting any error or not. And Java is really a hard programming language, and I believe it should not give me any error. So okay, I have forgotten a semicolon, and here as well semicolon. Now let's run this code and see whether we are getting any error or not. Hopefully we should not get, and yes, one steps unreachable return statement. Yes, so let me comment this thing then. Fine. Okay, now let's see. Okay, so time limit exceeded. I know why it's time limit exceeded, because we are not adding q dot add 0. We have to add the 0 index, right? Then only we can move to any other index, right? If we don't have anything in our queue, then where we can move? Now let's see. You can see that all the test cases are passed. So let's try to submit this code, and hopefully you can see that yes, we got our right submissions. And now let's move to the last programming language, that is nothing but C++. So okay, I'm here. I'm going to first of all create nothing but q. So I can say q is going to be nothing but you can say integer data type, and the data type I'm going to give is q, right? Variable name. Fine. And initially I'm going to add it into q dot push 0. Fine. After that I'm going to maintain a set. So I can say set, let it set, which is going to be integer data type, and the name is visited, we can say in idx, right? And the second thing which I'm going to do, value. I hope this makes sense. Once these two are also done, so we are going to say nothing but we are going to maintain a hash map. So we can say dictionary. So I'm going to say unorder. So here I'm going to say map. This is going to be integer. So integer comma, and the another one is going to be vector, right? So we can say vector. I hope this makes sense. So once this is done, so we are going to say nothing but the value, that variable name I'm going to give dictionary, and I'm going to say first of all is visited idx dot add, or we can say push, right? Push of 0. Fine. Now I'm going to use a BFS, but before that I'm going to traverse it. So I'm going to say traverse over this particular array for int I0 I less than n I plus 1. And what is n? N is nothing but length of an array. So that also we need to calculate. We can say rr dot, or we can say nothing but size, right? So this is vector, so we can say size. Fine. So we are going to say we can say dictionary of arr of I should be push back I, right? So this is we have done. Once we have done this, we are going to use a while loop. While true, we are going to say int size, which is going to be nothing but let me let size. So this is nothing but going to be q. We can say our q size, right? So q dot size, and we are going to say for int I is equal to 0, I less than size I plus plus. We are going to say int data is that is nothing but q dot front, and we can say q dot pop now, and we can see if data is equal to n minus 1, you can simply return that particular steps, and step we also haven't defined, so let me define step as well. So I'm going to say step is nothing but initially 0, and this is going to be integer data type, right? So once these all are done, so we are going to say fine, but if it is not the case, then if data minus 1 is greater than equal to 0, if it is greater than equal to 0, and we can say uh, this is visited, right? So we can say what is that? That is a set. So that is visited dot find, is visited idx dot find that particular data minus 1 is equal to is visited dot idx dot end. Then we can say it is a particular valid index. We have to move to that particular index. So let me write here bracket, one more bracket, and that is going to be nothing but one more bracket here as well, right? Fine. So once this is done, we are going to say nothing but we are going to say first of all add these things is visited idx dot, you can say insert, let me write insert, you can insert this particular data, so I can say data minus 1. I hope this makes sense. And also you can say q dot push data minus 1. So once this is done, I'm going to copy these things, okay, and I'm going to paste it, and here I'm going to say just nothing but data plus 1. So I'm going to say data plus 1, and here also I'm going to say data plus 1. Fine. And here also I'm going to say data plus 1. And one more thing, data plus 1 should be less than n, right? So it should be less than n, and here data plus 1 should not be present in our set as well. I hope this makes sense. Once this is done, we are going to say if data, okay, now we are just left with that particular thing is visited value to find our arr of data is equal to our is visited dot we can say value dot end. Then we can say this is also not present. So first of all is visited val dot insert this particular array of data. Once this is insert, we are going to say traverse over this, right? So for in data, or we can say value, we are going to say dictionary of arr of data. So we are going to say nothing but we are going to say if value also, if is visited dot we can say value, if is visited idx dot find that value is equal to is visited dot end, then you can say you can move also that particular part. So we can say we are going to move to that particular part is visited dot, first of all insert that particular index as well, so that we cannot go further in future. So is visited dot insert that particular value, and you can insert in your queue as well, right? Queue dot push this particular value. I hope this makes sense. Once this loop is over, we are going to increment our steps. So we can say increment our steps. So this loop is over here. So step plus equal to 1, and then you can simply run this particular code, right? So let's see whether we have done any mistake or not. First thing I can see here only, right? And second thing they have done here is visited dot index push. We don't have in insert, we have insert. Fine. Now let's see. So in step 0, again forgetting a semicolon. Now let's run this code. Hopefully now let's see whether we are getting output or not. So we got a lot of error today, right? Again, one more error is listed. It should be the IDX, right? Do we have any more error? Let's see. Hopefully you can see that all the test cases are passed. So let's try to submit this code. And this is the last programming language we have done with Python, Java, and now this is with C++, right? So you can see that it also gets successfully submitted. So this was the problem. I hope you understood this. If you learned something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.